and speakers so that we can start off. In the meantime, allow me to welcome you and also request you to let us know who you are, where you're joining us from, name, which institution you're from, and where you're joining us from, which country, which region. Do that on the chat box. Just type of the chat so that we are able to capture our participants. And Nancy, maybe you could share the slide.
Screen sharing. Okay, double click to enter full screen mode.
Thanks, Catherine. Yeah, let's continue introducing ourselves, who we are, where we're from. Yeah. Good. Thank you. I think we can start. Nancy, if you can put the slides on slideshow. Thanks, everybody. I can see people joining from different parts of the world, parts of Africa. We're really happy to have you here. Yeah, thank you so much, everyone coming in. I think it's a good time for us to start off. We already have close to 60 participants, so others will find us on the way. Again, good morning, good afternoon, or good evening, depending on where you're joining us from. My name is Johannes Atella. I'm Director of the Africa Research for Impact Network. And today I will be chairing this particular session. There seem to be people talking on the background. Can we mute everybody so that we... Yeah, so thank you so much. So again, on behalf of the Africa Research and Impact Network and partners involved in this initiative titled Leveraging Artificial Intelligence for Climate Resilience in Africa, we take this opportunity to welcome you to this discussion or this conversation today. We are today introducing to you a very innovative, novel initiative that is focusing on ways in which we can leverage artificial intelligence to support climate resilience in Africa. You know that climate change is the biggest challenge that Africa is facing today, both in terms of the development aspirations, but also in terms of the welfare or the well-being of the African people. And most importantly, the vulnerable communities continue or are the most affected by these impacts of climate change. Therefore, leveraging opportunities to really support actions that enhance resilience of our people very important. A technology that is being pioneered in different African contexts, different African institutions, policy institutions, research institutions are passionate about artificial intelligence and how the AI itself can be applied to provide solutions to a number of challenges that Africa faces, and most importantly, the issue of climate resilience. So while we know that there is a lot of excitement about artificial intelligence, and going by this webinar, we got almost 400 registrants for this particular sensitization webinar. There's a lot of excitement, a lot of interest, a lot of passion. There is still a big question around really what does artificial intelligence means for Africa? And most importantly, what does it mean in the context of the challenges that we face? How can artificial intelligence be of value to actually addressing the challenge of climate change. We know adaptation is a major challenge, and building resilience is a struggle for most African countries who have actually developed commitments through nationally determined contributions. And in those commitments, adaptation and building resilience is critical and central in those plans. But there is a big struggle in terms of how really do you finance resilience? How do you track resilience? How do you report? How do you create early warning systems and data systems that can really catalyze effective resilience? And that is why this conversation about the role of artificial intelligence in catalyzing those particular processes is critical and timely at a time when this discussion is also taking place at the COP, or Conference of Parties, the 29th Conference of Parties taking place in Baku. So this conversation is very critical, and I want to, again, welcome everybody that is interested to really engage and continue contributing to this debate. The webinar we have today is, as I've said, is a conversational webinar. We are trying to explore and just understand what is happening in this space. But at the same time, we do expect to learn from you what you are doing, what your thoughts are. How can we really come together, share some of the existing ideas, information, actions, or activities, interventions, so that we are able to understand how artificial intelligence is already being embedded in the Africa's resilience ecosystem. And our program today, as you see on your screen, we have a range of presentations that are going to be made. At the end of the webinar, or at the end of the presentations, we'll have a Q&A where we will really expect you to share some of your experiences and ideas with us so that we can enhance this particular initiative. So yeah, this is the program, as you can see, and yeah, we have about 4 presentations, which will not take quite will take not so much time in that sense. Next slide. And so just before I invite our speaker to, first speaker to give the opening remarks, I just want to give you a quick overview about the ARIN network, which is actually convening this particular platform or this particular webinar. So the ARIN network is a network of over 200 researchers and policymakers spread across 36 African countries. Next slide. We are based in Nairobi, but at the same time, we have a number of networks or focal areas across the continent. This diagram shows some of our thematic areas. These are some of the topics that we work on in terms of research, in terms of policy. As you can see, we work on issues of sustainable development, innovation, and technology, which is quite critical when you talk about AI. We work on issues around cities and resilience, agriculture, and forestry, mainly sectors which have been identified as critical for Africa's development in line with the Africa's Agenda 2063. We have a number of analytical approaches you can see on your right, including looking at policy analysis, research, and forecasting, capacity gap analysis and support, knowledge systems, business, financial models. We also focused on building partnerships and strategy. Next slide. And as said, the mandate of the network is that we offer a platform for researchers to share their work. So in so doing, we do consolidate evidence from different African contexts and try to use that evidence to form what I call a collective voice for Africa. As you know, that Africa is very diverse and heterogeneous in its own developmental and knowledge systems. So what we try to do is to ensure that we really bring the different contexts together so that we have sort of a concerted or a collective knowledge leadership in Africa. And in so doing, we are able to build a very strong evidence base that could support transformative policies, but at the same time support capacity building, including the work that we are doing with AI today. We have a very good strategic presence in Africa. As you can see, we are spread across 36 African countries, and we have focal points in the five regions of Africa: South, West, Central, and Francophone, East Africa. But also we have a diaspora link where we try to bring the Africans who are living in the diaspora to really come and contribute to the knowledge systems in Africa and be able to support some of the programs that the African governments and stakeholders run. We have a wide stakeholder database, more than 5,000 stakeholders who are spread across different institutions, governments, think tanks. And the idea is to ensure that some of the strategic critical evidence reaches or reach a wide cadre of people, a wide cadre of stakeholders who then can take them up and use them. These are some of the flagship initiatives that we are passionate about. Africa-led Resilience and Development, Africa Policy Fellowship Program, where we are running a fellowship program with the 200 fellows that I talked about, and we try to provide them with mentorship. We try to also link their work to policies and also opportunities for investment. So we try to make the African scholars' work to be visible, which, this has been a gap in the sense that a lot of the scholarly work that we see in the global space are actually from the global north, and we don't have a strong leadership and representation for Africa. So as ARIN, we try to create that space so that the work that African scholars do can be visible for policy support, but also for investments and decision-making processes. Evidence synthesis and translation is very important. We do produce the Africa Annual State of Evidence Report, and this mainly focuses on, the evidence gaps and needs, and especially on some of the topical issues that African governments are actually looking at. We are very passionate about demand-driven research, where we try to get the expectations or the aspirations from the African stakeholders, the African governments. What kind of evidence do they want to see being produced? What kind of technologies do they want to see being promoted? So this is also part of the work that we do with the AI work, because there's a huge demand for that. And of course, there are ongoing initiatives which you can see. And in these initiatives, we try to bring a very strong thought leadership with regards to resilience, and in this particular agenda around climate action, we are playing a very critical role, not just at the national level. We are a part of the Africa Group of Negotiators expert group. We are working with the UNFCCC to support adaptation work. So in other words, the work we are doing with the artificial intelligence agenda is very critical in terms of linking into these very strategic policy spaces. And I think this is my last slide of introducing ARIN. I want, therefore, now to introduce our next speaker. But as I bring in Lois Chanda from IDRC, I welcome you to really link up with us so that we can connect, be part of our network, and we can work together to take Africa forward. So Lois is working for the International Research Development Center, IDRC. Based in East Africa, and she is actually the program officer responsible for this particular project that we are talking about. Hey, she's done a lot of work in the AI space, and therefore she's just going to give us a brief outlook in terms of the ambitions that she has, but also the ambitions that the IDRC has with regards to AI for development, and in this particular case, AI for resilience. Lois, you are more than welcome to give your remarks.
Thank you so much, Dr. And it's great to see so many people who have signed in. I totally agree with you that looks like artificial intelligence is really causing a lot of excitement. So what do we do with that excitement, I think, is a major question for all of us. So I'm really pleased to join this webinar and to explore how artificial intelligence can be leveraged to promote climate adaptation and resilience, as you have already mentioned. I'm a program officer at Canada's International Development Research Centre, and I'm responsible for a portfolio of projects within Artificial Intelligence for Development program. This is a big program that we have within IDRC. I am based here in Nairobi, which is IDRC's East implementation of Canada's foreign affairs and international development efforts. IDRC champions and funds research and innovation within and alongside developing regions to drive global change. Our mandate is to invest in research in developing countries, share knowledge with knowledge for uptake and for use by policymakers, private sectors, and other stakeholders. So ARIN, for example, becomes a very important partner of IDRC. So back to why we are here today. Like we've said, artificial intelligence has taken the world by storm, and there are varying opinions. There are optimists, there are those who have fear artificial intelligence is going to take our jobs, and then there are those in between. So there are lots of mixed views. But what's clear is that we are faced with a moment of technological revolution. So the big question, like I said earlier on, is what do we do as actors in different development domains? And for me, that answer is we explore how to seize the opportunities that are available to us. For many of us in this webinar today, we grapple with climate-related issues. That's the central point that we're discussing today, whether it's trying to understand climate change itself or devising adaptation mechanisms to build resilience. AI provides another opportunity for us to explore options to address climate-related challenges and strengthening the capacity of scientists to harness AI for climate resilience. Strengthening capacities of scientists to harness AI for climate resilience is therefore a critical step forward. Leveraging artificial intelligence for climate resilience as a program seeks to strengthen capacities, notably of emerging scientists, to leverage AI for climate action. It will not only impart knowledge and skills, but also it seeks to institutionalize these skills to ensure that they remain even after the program is over. Furthermore, cognizant of the gender gaps that exist among scientists, promoting gender equality in this program is critical. In addition, to encourage long-term impacts, linking capacity strengthening with the needs of the industry and promoting research to policy are key considerations for this project. To achieve these objectives, it will be beneficial to engage with diverse stakeholders in the African AI and climate ecosystem. Like I see, there are already 90 people online. So under the leadership of the African Research and Impact Network, collaborating with critical actors like the University of Nairobi and others, we hope to see an increased mass of African research leaders contributing to the application of AI to combat climate change challenges. And also, we hope to see greater uptake of AI solutions, the ideas that will emerge from this project. We hope that the ideas or the solutions will be useful to the private sector and the policymakers. So I look forward to insightful discussions this afternoon to also learn, to hear your perspectives, but this is not just the end of it, it's just the beginning. I also look forward to further engagements throughout the life of this project. Thank you so much, Dr. Taylor, and back to you.
Thank you, Lois, for those useful remarks in setting the context for the webinar. I now want to invite our next speaker, who will give us a brief about the AI for Climate Resilience project supported by the Canadian Institute for Development Research Center, IDRC, represented by Lois here. And Humphrey Gavey is also going to tell us a bit about the landscape of AI in Africa. What is the status at the moment? A bit of the initial insights that we've got from some initial scoping we've been doing for this work. And that will form a foundation for the next presentations, which are more specific and targeted different aspects of AI. So Humphrey, as I've said, is a research associate at ARIN and also a postdoc who is working on this particular project. Humphrey, you are welcome.
Thank you very much. Good morning, good afternoon, depending on where you're watching us. My name is Humphrey Gavey. The project Leveraging Artificial Intelligence for Climate Resilience project is funded by IDRC, as we have been told. And the scope of the project is Africa, and it is focusing on capacity building, especially of the early career researchers. The implementing partners are ARIN, the University of Nairobi. We have Makerere University, and we also have the ARIN regional focal points and institutions that are in South, West, East, and Francophone Africa. To begin with, the context of the project, climate change is a global present challenge. And that is why even currently we have leaders.
And most of the curriculums take a while to be able to update, right? So you'll find that in a typical university setup in Kenya or in any other African country, the curriculum is 5 years old. And so even if advanced analysis methods were in that curriculum, they are as old as that curriculum. And that sometimes can become rigid, okay? The other thing is AI changes so fast. The technology that was working in the last year is not the same technology that we need now or that we're using now. So if the curriculum is rigid, then it makes it difficult to be able to build capacity, to build students in terms of AI, okay? The other one is on ethics and policy. There's ethics when we're using AI. So the first thing in many of our countries is to say that because there are ethical issues, we should not use AI, okay? And sometimes we make a blanket decision. There's an example in Kenya, I think in the last year or in this year, there's a group that came and was scanning people's eyes, right, for different purposes. The government only realized it later on, and then there were ethical issues, and the entire thing was stopped, right? In many instances, we do not have policy to guide AI and how it is being used. The final aspect is, you remember when we were speaking about the introductory part of this part, our machines need to learn, our machines need to observe, our machines need to be taught. So we need a lot of training data. As a human being, imagine you wake up at 6 o'clock in the morning and you go to sleep at midnight. So that is 18 hours of observation, of learning, of interacting, of reading, of doing different things. So as a human being, you are consuming a lot of the information, and this is the information that is building on your intelligence. They're making some of them are emotional, some of them are physical, some of them are logical, some of them are not logical, okay? Some of it is structured, some of it is not structured. And you are consuming this as a human being for the entire day to be intelligent. The computer needs much more. Since our main traditional knowledge has not been formalized, it means we do not have the data to be able to teach computers. The cost of labeling data is also quite high. So I'm just highlighting these as part of the challenges. this is not complete, but this is part of the challenges: technical, knowledge, ethics and policy, and then data management and data for training the models that we need to use. Okay, so what are the opportunities? And when I speak about these opportunities, I'm going to try and go back to the challenges that we have. And I'm going to use examples from geospatial sciences, from geoinformatics, which is important for climate resilience. Let's take an example. We want to understand the effect of climate on land, on the productivity of land. So we need a lot of data to be able to compute, to be able to train our models. At the moment, they are cloud-based data. Google Earth Engine has terabytes, potentially petabytes of data. It also comes in with coding platforms, visualization platforms, and a way to integrate it to other platforms. So that is an opportunity that we can use for our capacity building. Practically, this is what I'm talking about. The curriculum may have spoken about introduction to remote sensing, okay, for climate change mapping. And 5 years ago, it was defined that, hey, the available data is this, and this, and this, and you can use your desktop computer to be able to analyze it. Now we have an opportunity that is a lot of data in these particular platforms. I don't think it will be a crime for a member of a faculty to adjust their notes and be able to use this kind of tool in order to be able to meet that objective of the curriculum. Okay. On the right, then we also have, there are just so many sensors that are coming up, and I'm going to use, for example, the European Space Agency kind of sensors. You have sensors that can provide you with very high resolution data, moderate resolution data, and low resolution data in space. You also have sensors that can give you information in time, right? And then beyond the kinds of sensors are also different. You have passive sensors and you have active sensors. Beyond that, you also have analysis-ready data. So I look at these as an opportunity, data that we can use for training our models and tools that we can use for running our models. Then I have an example down there, fields of the world. This is a comprehensive data that has been structured, has been labeled, and you can use it for the sake of mapping agricultural lands. So one opportunity that we have is in terms of available data from different sources that we can be able to use. Okay, so again, this is not complete, but it is an indication that there's an opportunity for data that we can use for the sake of building capacity for AI use. Number two, there are resources. There are available resources that we can use for learning. One of the resources is by Microsoft. It's called AI for Good Lab. And this resource, it includes projects that have been done. It includes publications that have been written. It includes data that has come out of this. And it includes also guides that we can use for learning. Another example is Google AI. So there are APIs that, again, Google has developed that we can use for learning. Many of them are very gentle. The learning curve is very gentle. From the basics of AI, from the basics of machine learning to the very advanced levels. These are some of the tools that we can use. Another example, Meta, Facebook, has one of the highest resolution population data sets that we have. And they've also documented how this was generated. They've documented the APIs. They've developed the infrastructure that we can also use. Other examples. Keras is a library, is a tool for AI, okay? And these have been developed, have been made public, and beyond making them public, there are also documentation that we can use to learn. Okay. Then there's Collab. Again, this is a Google generated library. We can collaborate on these, but we can also build models that are online and other people can access them and use them, and there are libraries there that we can be able to use. So that is an opportunity for learning, for implementing, for using AI in climate resilience. I'm almost coming to an end. Another opportunity that has also been highlighted is partnerships. Okay, a few regional institutions are coming up in Africa. Again, this is not complete, but a few of them are coming up in Africa and are focusing on AI. I'm aware that even at the University of Nairobi, the Center for Climate Change Adaptation is also involved in this. Okay, so there's an opportunity here to collaborate with these, and also for these kind of initiatives to collaborate with each other to promote the learning. And I like the work that ARIN is doing in facilitating this kind of collaboration. So there's an opportunity for partnerships. And when you're talking about partnerships, what is it that we can actually do? One is staff exchanges, right? Student exchanges. We've spoken about faculty gaps. There can be faculty exchanges, okay? There can also be project ideas where you come up with project ideas and are able to work on these project ideas collaboratively, right? So there are opportunities for partnerships. Then opportunities in terms of curriculum. So I'm saying within an institution, one of the opportunities is to create centers or ideas. I'm calling it ideas labs, where students, where faculty can have a chance to delve into AI. I'm going to give an example where I was learning for my master's and for my PhD. The faculty just decided to create an empty lab with only computers, a whiteboard. So you can go sit there and explore ideas. Our typical labs in Africa were designed as physical labs, okay? We have a big computer, big in size, right? And then there's software there that you're supposed to use. And sometimes there are no software. And that is what we still have, okay? So we need to go beyond that to a place where we create a lab where faculty and students can hang out just for the sake of learning, okay? I also think short project-focused AI courses within the faculty. If it is a faculty of engineering, okay? If it is a faculty of mathematics, for example, you have short courses. It can be 6 months, it can be 3 months, and this is delving into AI. And especially if it is project-focused, so that people are not learning the theory of AI, that are using AI and implementing AI, okay? Although some of our curriculums are rigid, but in many curriculums, you have a unit, you have a semester when you are to take the students through some case studies. I believe that is an important situation where you can integrate AI as a part of case studies into learning, as a part of case studies that build on the curriculum. Then innovation challenges, again, has been highlighted, okay? There are some topics that emerge so abruptly that we may not have foreseen them in the curriculum. For example, when we had COVID, when we have pests and diseases that are coming up, when you have locust invasion, right? We cannot develop a curriculum, we cannot develop a plan for addressing these. We have to use the time and the chance to be able to sort out these. So I see a chance for innovation challenges to address this kind of emerging problems, okay? And when we have these innovation challenges, it is important to identify a few experts who can guide the students, who can guide the early career researchers as they work through the projects. One of the things that I've noticed also lately is that innovation challenges are popular and the organizers assume that the students and the early career researchers have the results. But in many instances, these are also people who need to be guided. So the few faculty members that we know can be used to be able to guide students and to ensure that that whatever the students are doing or whatever the early career researchers are doing is guided in a way that is also formal and guided in a way that is also systematic. There are also, we can also engage in projects. Recently, there was a call for climate change AI, right? This was a big project. So these are some of the things that we can engage in, again, through collaborations. EO Africa, I think for the last few years, has had projects that encourages the use of AI. That is an example. Science for Africa. Yeah. Bill and Melinda Gates also every so often have calls for research. These are opportunities that we can use to build capacity of the faculty, in terms of the infrastructure, in terms of even the case study areas, so that we are able to learn and so that we are able to build capacity in a way that it will be beneficial for Africa. In conclusion then, AI provides opportunities in research, job creation, national development, and climate resilience. We need AI to sort out some of the problems that we have. When you're thinking about climate resilience, there's a lot of data that we are not able to handle using traditional ways. AI can support us, right? There are technical challenges, there are knowledge challenges, there are policy challenges. However, the positive is that these can be mitigated by learning from other places and by using existing infrastructure. Number 3, partnerships and networking, right? The few institutions that are coming up that are leading the way, this is an opportunity for networking. An opportunity like the one that we have now is one for networking. So I believe it is through partnerships, networks, that we can be able to grow together. So in summary, that is what I had for our discussion today. That is what I had in terms of our discussion today. And the discussion is that 1, AI is good for us. There are challenges, but we can mitigate these challenges by relying on the opportunities that I've been able to highlight. The data opportunities, the learning resources opportunities, the partnership opportunities, and the funding that is coming up to address AI issues and climate change issues. Thank you very much.
Thank you very much, Francis, for that very integrated but also very insightful presentation. I guess most of us are learning a lot from what you have just presented. Two things emerge from your presentation, that there are already a number of tools and opportunities that can be pursued to tackle the challenges of applying AI to solve some of the problems that we have as a continent. And thanks for sharing those. But fundamentally, I'm actually, surprised, or intrigued by the point around. I would frame it as decolonizing our systems to be able to be AI compliant. So there's the one side, we have the issue around lack of adequate infrastructure that could really support application of AI, data infrastructure, but also the software infrastructure in terms of the modules that are there. But you've brought a very critical point again, that the existing, even where these infrastructures exist, their ability, flexibility to be able to enable uptake of AI is a major challenge. So they need to really have some of these systems that could be, decolonized in ways that make them more adaptive and sort of open, enabling them to absorb AI ideas for the sake of application. That is very, very fundamental. Many other things that you've spoken about. So thank you so much for that. But before you go, there is a question I need you or Humphrey to respond to. Now that you've spoken a bit about where or areas where AI can be applied. There's a question by Marie Raria, who asked about the potential for applying AI tools in addressing the gender inequality gaps. Any thoughts on that, Francis? Or Francis, you can start, and Humphrey can add something.
Okay. Yeah. So maybe to try it, and I can also put it to a question that has come up. One of the challenges that we've had in Africa, particularly in these STEM-related trainings, STEM-related capacity building, is gender inequality, where you have the males having a better chance to access STEM training and STEM capacity building. You'll notice that most of the tools that I'm talking about are tools that are now open, they're available, they are accessible. So one way in which, even in terms of capacity building, the tools are available for everyone. When you go to AI for Good and you are looking at the material there, you do not have to say that I'm male or female. So that's one of the opportunities to ensure that this information is accessible. Number two, and I want to relate it to the second question. You remember when I was talking about natural language systems, right? And now, if you're going to use AI, and especially if you're going to rely on traditional knowledge to be able to build climate models that are resilient, women are, in many instances, the most affected by issues like climate change. And now we are providing a model where you don't have to have gone to school, you don't have to have been a professor to be able to influence these models. Your narrative can be captured and used in improving decisions. So I think that is the example that I want to give. So we develop systems that are not male focused. The eye of the AI is not masculine, is not gender insensitive. It will accept data from every source. And that's a good thing about AI models. You can ingest as much data as possible. Thank you.
Yeah, thank you, Francis. And just to add to Maria, is that one of the other projects we are involved in at ARIN here is to develop indicators, gender responsive indicators. So we are also looking at opportunity to perhaps apply AI in terms of aggregating some of the gender responsive matrices that then could really strengthen the gender voices in much more equitable way in research and policy domains. Because of time, I want to bring our next presenter, who he's going to dig a bit deep into the aspects of tools and some of these frameworks around AI. So Alex Manuele is from the University of Nairobi, and he's going to talk about the critical role of big data, artificial intelligence, and machine learning algorithms, analyzing large-scale environmental data to predict climate trends, enhance disaster preparedness, optimize resource use. So we are beginning to go to where the rubber meets the tarmac. And in this presentation, we can already see that some examples around the link between AI and climate resilience will be emerging. Alex, you are welcome to share your presentation. And I want to be very strict with time. I'll give you about 10 minutes so that we have good time for questions and interactions. Over to you, Alex.
The host, I may differ about that, and hello, host.
Hello, we can hear you.
Yes, I was given like 30 minutes to present, so my conscience told me that I should be having 30 minutes. So my slides presentation maybe was about to take 30 minutes. 10 minutes maybe will be a bit low, and maybe I won't cover the effect as like 10. Maybe if you can save the minutes, I could really appreciate.
Yeah, Alex, that's understandable. Just try to highlight the key issues. We might add you a few minutes, but we don't want to go beyond 15 minutes for your presentation. So I guess you will be able to balance. Thank you.
Thank you. Thank you. Thank you. So I'm Alex Munyole Luvembe. I recently graduated from Shanghai University with Doctor of Engineering. And I'm trying to actually get to the industry. So in this role, I was given talk about critical role of big data, AI, and machine learning algorithm in analyzing large data scale environmental data. Most of my work, you can get it at Google Scholar as the given link there, but mostly I've been focusing on fake news and misinformation detection, which has been my core area, but this is a multidisciplinary area, which also loops in climate change, which is about detection, how the trends of climate, temperature, and all that aspects move into part of our human life experiences. So in this presentation, actually, I'll talk about big data analytics, role of AI. In fact, part of the just a minute. When I actually get here, actually, I'll go into practical aspect of it, and we'll when I get up here, we can actually get to practical aspect of AI and how it influences our way of thinking about climate change. Then after that, maybe we can have final thoughts. So basically, as my four presenters have just highlighted that big data, and mostly they have highlighted AI, it has been applied to various fields for like health, transport, and many other fields like climate change. But in this current allure, we're witnessing that the AI is being hyped in terms of climate change. So this is part of it because it's trying to influence how climate change should be done in terms of conservation and resource management. So this is so important in current terms because we have pollutions, we have very many things happening with our immediate environment. So AI and big data actually tries to come in and influence how we can actually try to mitigate all this, what's happening around us as a society and part of our world. So big I, in essence, facilitate collection. This means collection of data from various sources, radar, satellites, and all that. It leads also to analysis and interpretation, how this data can actually make informed decisions for policymakers and give us what can be done to mitigate this climate change in terms of farming, in terms of pollution, and so on. So in terms of big data analytics, big data, as we have actually seen, is very vast. And it comes from various sources. This can be in terms of satellite, sensor data, weather forecasts, and so on. So this data is very large, as this diagram can easily see here. So big data in terms of explanation can be equated to 3 V's, which means volume. It comes with various file sizes, records, tables, files, variety. It can be in terms of structured, Structured in this sense means that this data can be easily fit into Excel data sheets, which means it has the date, time, and all that. At the same time, it can be unstructured, which doesn't need to follow structured point of view. It can be streamed in a way that you can easily not in a position to actually process it in a given form. So this actually needs processing. So it can be semi-structured and all that. Then it also has velocity, like social media. All of us, we use X, we use Facebook, and we see how the intensity that data comes in. So these three aspects of volume, variety, and velocity, which equates to 3 V's, characterizes the big data. So where does climate data come from? Various sources. We have geospatial, we have satellite imagery, which in this case consists of land use and all that. We have sensor and IoT. Then we have social media. Social media, all of us, we have subscription to social media like X and all that. And then here we can easily get the public sentiment. How are people talking about climate change? How about talking about the Carissa, which is a semi-arid? How are they talking about certain aspect of today it has not rained? So we capture this through social media. And then we have experts in science. So they get this data through climate models or ecological studies, and they give us this data. So this data should be harmonized for us to actually have a clear insight how climate aspect is going on within our environs and within the world. We have weather stations where we can easily capture the temperature and the humidity, radar, mobile phone, and historical information. So why big data? Big data is so crucial because it leads us to making informed decision. If you are a policymaker, then we need data for you to make sound and actionable take on what this data tells. You can inform the government, non-governmental organization, and other policymakers, which can easily rely on this data actually to make key decision making. For instance, like in this example I've just given, like here, we can collect big data from various sources here. Then we can easily assess the climate aspect of it, like risk analysis. So here we use like deep learning tools to analyze this climate data, topography, and so on. So this can easily lead to making this decision, which I'm trying to actually analyze. So impact, how is this climate data doing to our agriculture, our farming? Then how can we actually use this analysis to adapt our measures to actually improve agriculture or maybe this climate change? Then if it's to the extreme, how can we mitigate the risk? So this is what actually big data does in terms of highlighting climate. So why big data? Climate change? This is a question. So big data is so very critical in essence. Like big data can help us, scientists in climate change can easily use big data to detect patterns. Techniques which is almost applied to this essence is like one, numerical weather prediction, global climate models, and then regional climate models. all these techniques can be actually used by climate scientists to identify patterns and trends. For instance, rising global and so on, actually to make informed decision to and deliver it to policymakers. It can also use to identify anomalies, and this in big data we can use extreme event
we can also the beta. Yes. No.
Let's mute all participants except the speaker. Please, IT team. You can proceed. Yeah.
Okay, thank you, host. So big data has various advantages. For example, as I was going through, the second aspect is that we can use big data to identify anomalies, and this we can use techniques like time series. In this aspect, time series actually relates to correlation. Mostly correlation deals with statistical aspects and extreme event detection and data visualization. All these techniques that is employed in big data can be used to identify anomalies and maybe try to identify events that deviates from the norm, e.g., what is not expected and what is unexpected. Then also other aspect we can use techniques such as machine learning and deep learning methods. These are the most techniques which we can easily use to detect the relationship between different factors, which can actually impact climate change. For example, link between greenhouse gases emissions and global warming. So all these aspects play part in using this big data to actually correct or mitigate aspects of climate change. So what are these really examples of application of this big data in solving or trying to mitigate climate change? We have energy consumption and optimization, whereby we use smart grids and predictive maintenance. These are the core part. So big data try to optimize smart grids, try to find the easiest way whereby we can easily utilize or find the minimum resources that can be used to fill the cup of where the maximum aspect can be used to actually maybe the maximum part can be used to make a loss. So energy consumption, big data tries to find the optimized way where we can actually optimize resources. In terms of smart grids, predictive maintenance, this try to minimize the losses which can equally be used to accord those resources to other uses. And then you also have agriculture and resource management, where actually big data can be used for precision farming, water resource management, as we can easily see from this picture here. Big data can also be used for sorting. That means waste management and also air quality. If we sort the resources, if we sort the waste into their respective categories, then we are being assured of air quality monitoring and safety. So I won't go to summary because I've been told about the time, but that's what we have been covering in the last slide. So here, maybe the host can give me more time so that I can explain more.
Can I give you 1 minute? Is that adequate?
Yes, maybe 1 minute per slide. That can be okay because this is more practical.
Okay,
right?
so for the rest of the presentation, give you 2 more minutes.
Thank you. Thank you. So AI and machine learning algorithms. So as my predecessors have just said, like Francis Solo and Dr. Ajedi, AI and machine learning, this is not a new thing. It has been there. Only it has been hyped in African context. And I will try to explain further in my slides, because perhaps if you use your smartphone and a message being delivered to you by your friends, relatives, or anyone else, that's AI. So the AI has been with us. It's only the African context cannot actually realize that that's AI. Only that in climate change, that's where the rubber meets the tire. We haven't explored it fully. But every time since the smartphone came, we have been having AI. It's a hyped technology, but we don't realize we have it. It's only the application to different categories of industries, whereby we actually need to commercialize and we give solutions to society, like in climate change, where it can change lives of the society. So in this aspect, I'll be tackling AI and the machine learning algorithm. Being part and parcel of machine learning, I've done various projects of machine learning and AI. Part of my work has been trying to detect fake news. And most of my work for my PhD, I've been doing this. And I saw immense solution for AI in terms of detecting fake news and mitigating climate change. So in this aspect, machine learning actually is the study of algorithm. Mostly in machine learning, we use statistical algorithm. This means it needs labeled data. This data needs to learn. So this data is labeled and you give it a different data, which is unseen, and if it learns from unseen data and you have labeled the seen data, it can make a detection what this is. And then AI actually is an array of technologies. So it allows it gives a leeway of computers to perform advanced function that as human beings can actually perform. So these two aspects are intermarried. So in this sense that machine learning is actually a subset of artificial intelligence, which is not new. If you are using a cell phone, then that's artificial intelligence. So it's not something new. Maybe being incorporated to climate change, that's where the newness in quotes comes in. So, but with time, this is becoming very, very complex because of the new data we get, the new algorithm being developed. So it gives it more power and that predictive ability to see what's happening, because it mimics on how we think. That's why we have large language models. ChatGPT is coming up, and that's why advancement is being accelerated. So in machine learning, actually, we have various algorithms like supervised. We have support vector machines, k-nearest neighbor, random forest neighbor bias. These are supervised. Which means you need to label the data for it to give you what you want. It's like classification. Classification means you label the data that it gives you what you have attuned the machines to give you. So
Alex, try to summarize now in half a minute.
Okay. So in artificial neural networks, we have artificial intelligence and we have deep learning. This actually goes deeper and it uses various deep layers. So these are use cases where AI and machine learning has been applied. We have new real-time flooding mapping. Background, this Hurricane data set which was used was 2018. These are the cases. Climate change real-time.
Thank you. Thank you very much, Alex.
Thank you.
That was very rich information there towards the end. And I want to urge our participants to look out to our trainings that we will be delivering through this project. Some of these details that Alex is already presenting will actually be given out. So we'll have more time through the fellowship and the modules that we'll be delivering in collaboration with the University of Nairobi, other universities. So be in the lookout if you want to learn more and engage more. I want to bring our final presenter because time is almost out. Dr. Randani Mbova from University of Wits. And Randani is an academic fellow in machine learning at Queen Mary University of London. So Randani, I want to give you, because we're going to talk about opportunities, AI. So you could spend less than 10 minutes if you can, so that we save some time for engagement. Over to you, Randani.
Just 1 second. Yeah, if let me see if I can share my screen. I think I can. I'm hoping I'm audible. Is that?
You're very audible.
Thank you so much. All right, cool. I will certainly try and just move some things around. I'll certainly try and save us some time. I will focus on the opportunities that that are presented. If you see my first slide, I wear a few hats. So what actually I'm an associate professor at the University of Witwatersrand here in South Africa. I'm also a Google DeepMind Fellow at Queen Mary of London. And the opportunities that I will focus on initially will be around the work that we're doing as part of essentially a research community of AI professionals as it relates to climate in Africa. Get my slides. And this is essentially a bit about where we see AI going globally, as well as some opportunities, not all, and some challenges. And we'll talk about this grassroots effort. And I'm pretty excited about the work that has been presented today. And I'm hoping we can collaborate on multiple fronts. I'm not going to spend too much time on this slide, but this is just setting out the current evidence on the potential impact. And I think Humphrey and a few other speakers have already mentioned that Africa, despite being not the highest emitter, were very, very vulnerable. As you can see, the potential biodiversity losses, mortality.
Not sure if we are seeing the slides.
Not sure if you're seeing the slides. Okay. Oh, yes.
Unless it's just me.
No, I think you're right. I hope you can see them now. Okay, cool. Yeah, so this is where I'm from. This is the cover of the slides, and I think I've glossed over this. And I'll talk a bit about this Afro-Climate AI initiative and how it might be a natural fit for some of the work that you guys are doing. And the context I was setting is around, how perhaps the effect, particularly when you start looking at scenarios per IPCC's assessment reports, you see that there will be increased mortality, there will be increased losses in biodiversity and food production risks, and particularly obviously as the global average temperatures grow, the impact, as you can see from sort of like the color shadings, will be relatively high. And perhaps where we expect to see some of these events across the continent would be, you expect to see things like droughts and wildfires in Southern Africa. That's where I'm from. I'm from South Africa. And perhaps in regions like East Africa, you'll start seeing things like, some levels of snow might even occur, but also you might see droughts persisting as well as extreme precipitation. I think a lot of the speakers have talked about the sort of role AI can have in different facets of the ecosystem or mitigation and adaptation efforts. So I won't spend too much time there. But again, our focus as my work in my own research in the Climate AI has been in climate impacts. And again, understanding predictions, and our mission really is to understand, enhance predictive skill over Africa. But energy has been mentioned, enhancing transport and other emission sectors has also been mentioned, and food and security and agriculture. You can actually process data using AI. You can do monitoring, as well as again predict diseases, predict yields, and again as decision support to reduce some of the risks that are sort of accompanying climate change. I think a little bit of some of the focus areas. We work a lot in this quadrant. So the deep learning endeavor is actually where initiative like Africa Climate AI is necessitated, and we do workshops there on both AI and climate related research. We work also with the team at Data Science Africa, as well as Climate Change AI, which is where I found out about this event. But of course, there's quite a lot of space to speak with both local and regional weather centers, because you need data, and data is a key challenge as it comes to Africa, and we'll talk a little bit more about that. And perhaps you've seen a lot of startups like Amini out of Kenya, Instadeep out of Tunisia, but there's a lot of activity in terms of that element as well. And of course, you need the compute as well as the computational resources, and this is where initiatives like Google, NVIDIA, and IBM come into place. But again, this is just the overall sort of landscape of how this is going. But we'll talk a bit more about where we fit in terms of climate action. So the first thing is, when we talk about forecast skill, and we talk about how accurate our forecasts are when we predict a few days ahead, when we predict the weather tomorrow, the next season, and in climate change prediction, we talk about multiple decades. But what has been happening in this area is that because of increase in computational capacity, we've been seeing the accuracy or the skill of forecasting model increasing over time. And if you see that the top line often refers to, in the blue, there's the 3-day forecast. We're seeing that since 1981 to sort of the forecast skill increased by about 10%. The top line there is the global north, and the bottom line is the global south. And the reason is that there's always going to be a differential because of some issues that I'll highlight in the global south. So this, in keeping, AI has become a relatively big game changer, in that what you see there is that you're seeing that you can actually bypass the traditional ways of forecasting the weather in terms of building large systems of differential equations to focus the weather. You can start now train deep neural networks or graph neural networks. And one of the revolutionary pieces of work is a model called GraphCast that was released by Google. And this uses the graph neural network architecture to forecast weather in about the medium range level. The medium range level includes up to 14 days of weather. And this, if you look on the right, is the scorecard of how well it predicts relative to the traditional forecasting methods. And as you see, when it's blue, it means it's much better. When it's red, it's actually worse. But when you look at GraphCast, for example, and all the other machine learning models in this particular quadrant, you see that a lot of them surpass what is called the state of the art in terms of the traditional model, in terms of forecasting pressure, temperature, and humidity, as well as wind vector, and a whole lot of other variables. So this is an area of big attention for areas like Africa, where perhaps you might not have, the computational facility to build sort of the big systems of numerical weather prediction models, but also the space at which you can run the forecast using AI is about 3,500 times better than running multiple systems of differential equations. We talk a bit about this is the same quadrant of skill that we show there, but again, it outperforms what is the world's leading forecasts from the European Center for Medium Range Forecasting in this particular area. I'm going to talk a little bit more about that. I think the agro examples I think I've mentioned, there's been work on using sort of satellite imagery out of Kenya. We've been collaborating with the LDRI. I'll not, because of the time constraint, I'll skip that, but I'll focus a bit more on what we see in terms of the challenge when it comes to taking up. I've just advertised the deep learning or AI-driven weather forecasting. The next thing is, can we make it work for us? And one of the things that we see is that the problem in Africa is that we're losing climate data. In that what actually means is that the number of weather stations that we have at the moment is 1/8 of what the World Meteorological Organization suggests. And that is decreasing over time. And there are a few reasons for that. Some of that is declining investment in infrastructure, bureaucratic walls that sort of stop the data from being shared. So the data might exist, but not being shared. Or as Humphrey said, some of it is still in analog format. Because this large systems of AI that are forecasting the weather do not necessarily they work on open data. That means that you're not getting sufficient representation of African data in that particular area. And this is a big focus. And again, this is the similar graph. And if you look at the presence of radar over Africa, is pretty similar. The model that I was talking about there, that is the Google model called GraphCast. If you then try, and we did it as part of AfriClimate AI, we then say, well, how does it look when you're trying to forecast weather over Kenya? If you look at this graph, what it suggests here is that the lower the graph, the better. So if this is the error in forecasting geopotential is a measure of pressure. If you're looking at temperatures and if you're looking at precipitation in 24 hours. The blue line is over Kenya, the green line is over Africa, and the orange line is over Africa. It's actually showing, if you look at it in this particular way, it shows that this forecasts are the most accurate over Kenya. And that is very, very misleading. And the reason why that is misleading is because these models are trained on what is called reanalysis data. And reanalysis data does what is called an interpolation. So it's a model which assimilates observations. Therefore, in areas where you don't have observations, like in Africa, or perhaps in this case, even if you narrow it to a jurisdiction like Kenya, you get that the model just interpolates. And when you interpolate, in AI, there's something we call overfitting, where the model can actually learn very smooth functions relative to noisy functions. And therefore, because of the lack of data, you get misleading forecast results from the AI. And this is something that we must focus on and and definitely how we then improve on that. I talked a bit about the barriers on accessibility of data before. And again, it's about adherence to something like WMO Resolution 40, which is about how data is shared across globally such that the models can actually assimilate or take in those models. And again, there's some skills and technical issues in terms of that, and data discovery, as Humphrey said, about the data that might be locked in actual documents rather than databases. The policy landscape, briefly, is increasingly supportive. We've got a few countries that have adopted AI strategies, but what we see when we look at the policy landscape, we see that there's very little focus on the carbon footprint of compute, on actually the application of AI in climate-related uses. So there's still a need for us to infuse AI in policy discussions as such. I'll talk about AfriClimate AI. So mainly AI researchers and some researchers who do climate-related research. And what we're trying to do is address the climate data scarcity and also share skills. So you can have a hydrologist collaborate with a deep learning engineer and so on. We started in Ghana at the Deep Learning Indaba, which is organized by mainly guys from Google and OpenAI. And we take in about 800 students every year from across the continent with travel grants to actually teach them machine learning for a week with world-leading experts. This is the sort of like the team that runs the AfriClimate AI community. This year we met in Dakar. And again, as you see there, they're holding up a weather station because we've got a very interesting initiative as it relates to collection of data in that particular case. The community has people from over 24 countries. I think there are about 190 to 200 people who work in this particular space, and their interests for collaboration are diverse, from health, impact on health and prediction, energy, disaster risk management, and climate prediction is a big one, and that's one of our major focuses at the moment. Some of the activities that we've done is we've done sort of workshops in Nairobi. Actually, I was there in February of this year at the United States University with Applied Machine Learning Days Africa. We've done sort of a policy meeting in Germany with the United Nations University. We were at the Deep Learning Indaba, and we also gave a presentation in Nyeri in Kenya at Africa. We have our code and tutorials on evaluating sort of weather forecasting over Africa, like the results I showed you there on the bench. And we're also kicking off again a webinar series on YouTube in terms of that as well. But we do have quite a few capacity building efforts as well. But we also have technical projects. And one of them is to work on a new paper, similar to the lines that Humphrey is referring to understand the roadmap. What needs to be done? How do you understand the data problem? What are the ingredients and the role players that need to be there such that we can, yield a climate resilient Africa? And that's some of the things that we work on. We have something called Project Angalia, which is a Swahili word. And in that, we're trying to say, well, everyone is building AI models for forecasting the weather. But what we see is that if we don't put attention to what's going on in Africa, in that the data in Africa does not look like the rest of the world, you find misleading results, as I've just shown you. So what we do in Project Angalia is we're finding data sets that are representative, and we collaborate with organizations such as TAMO, which you might know about. And we try to create a data set such that if Google is building a model for forecasting weather on Africa, they actually test separately that it actually works for Africa. And that's what Project Angalia does. And this is going to be open source. And we've got a team of people of about 10 people that are working on that. There's actually a package that one of our team members have already open sourced called InstaGeo. It allows you to link on the ground data, such as crop yields at a particular farm, say in Kenya or in Mombasa. I don't think they farm in Mombasa though. Well, I don't know. But if you say you collect the yields in Kenya, for example, and then you have a remote sensing satellite that passes over anyone, such as Sentinel-1, Sentinel-2, we actually have a quick way through our InstaGeo package to actually link that and build a predictive model that takes the remote sensing image and your localized data to allow you to then, actually predict those yields in real time or detect changes in your land use in real time. And another thing that I mentioned earlier as well is the AfriNet, which is a new sort of initiative that we have where we say we've got about 200 people in our community, and they're spread in 24 countries. Now, Africa lacks open data in terms of weather stations. So we're actually giving them low-cost weather stations for them to actually work with. And then we have an API and database that supports that. And this is what AfriNet looks like. We will share the data openly. We have this weather stations cost about $150 each. And we beam them up into a single API so people can download it. And we integrate it with other sources as well. Eventually, again, they will yield things like fine-tuning of models of Africa and other initiatives. But it's still relatively in its infancy. We've got about 3 stations online, one in Tunisia. We're going to put a few in South Africa, and another one in Kigali. But yeah, I sped through the presentation. I'm sorry for that. But I'm very happy to chat. If you want to join the community, you can scan the QR code. You'll get a form where you can join us. You can email research@africlimate.ai. But I was really grateful to see the work that's being done here. And I'm really hoping that we can find areas of collaboration.
Thank you, Rendani. Very helpful. And apologies to our participants. This topic, I realize, really require good time to unpack the different facets of it. So kindly bear with us, and we hope that you are benefiting or you are learning a lot from some of these insightful presentations. Let me request that if you want to engage further with some of the initiatives that are being showcased here, kindly don't hesitate to contact the different presenters. We will also be sharing the slides so that you are able to follow on whatever could be your interest, because this webinar is really to create that sensitization about what is going on, and also to open an opportunity for the African researchers and policymakers to link some of those ongoing initiatives. I want to quickly, I know we are over time, but I want to beg for a few minutes of your time, maybe 10 minutes or so that we can conclude. I want to bring in Humphrey Egevi to just take us through the Q&A. I know a number of questions have been answered in the chat. Humphrey, you could take this up before I call upon Professor Lago to give some concluding remarks so that we can close. But you, Humphrey,
thank you very much. Yeah, thank you very much. Thank you very much, the presenters, for that quite elaborate presentations in different areas, opportunities, areas of collaboration and partnership. Maybe a number of questions have been answered on the chat box, but if we have any burning question that we think the presenters can help address, maybe you can raise up your hand so that you can ask 2 or 3 questions. Then I know the conversation will still go on, so we shall still continue to interact. Any question?
There are some unanswered questions on the chat. Humphrey, maybe you could bring them up as people think of their questions.
Okay. There was a question on seed technology. How can we be able to use AI in seed technology? I'll give one of the presenters to address that. How important is seed technology and seed industries? How can we use AI in that? And then also, how can climate financing, how can we use AI in climate financing on performance of enterprises? Maybe you can get answers to those 2 questions. Any of the presenters can answer that.
Humphrey, even attempt, I mean, it's not really my area of focus, but what often is happening in the seed technology in particular, I'm assuming here the question is referring to like seeds in terms of planting and agriculture. In my view, what is happening there is that there's a different area of AI that could have a large impact in that. Because in terms of seed technology, what you have to do there is do genetic modification such that you have a climate resilient crop and so on and so on. And there's big areas of AI in biosciences that then affect what, for example, the Nobel Prize in Chemistry this year was won by guys at Google who were working on protein synthesis using or learning protein structures using deep learning, right? So those sort of ways of exploring the parameter space of different, genetic makeups and finding different solutions in that space of possible sort of, climate resilient, seeds will come mainly from AI designs that are in the biosciences space, where they are solving for, perhaps, improved temperature thresholds, reduced moisture levels for seeds, and so on. So that's my view where that would have a largest impact. There's going to be an efforts that come from a bio and agro perspective.
Thank you very much, Dr. Rendani. Maybe Dr. Olo, is it possible maybe you bring in perspectives on how can we be able to use AI maybe in financing? And then there was also another question on indigenous knowledge. How can we really be able to integrate AI in indigenous knowledge? Because that is an area that is really emerging, and of the opportunities that are coming in climate resilience are combining indigenous knowledge. So how can we integrate AI in that?
Okay, yeah, so maybe the point that I can make is obviously there's no money that can come from AI to finance projects. But in terms of guiding the priority areas, in terms of guiding priority areas, then it could be possible to use AI to identify areas for funding. In terms of indigenous knowledge and how AI can be used in it, let's take the example of ChatGPT. ChatGPT is using natural language, and in many ways, it's a learning platform where if you accept, and I know now they even ask you to choose between 1 and 2 answers. So if you choose one, then they take that as the better answer, it will be used the next time. So similarly, our indigenous knowledge are in formats like natural language systems. They are in formats like narratives. They may be in formats such as art, right? So then it is possible to bring in insights from these natural language kind of artificial intelligence models to learn from the indigenous knowledge systems, and then that indigenous knowledge can then be used in climate mitigation. So there are potentials there, obviously, to be explored. Yeah, even with a few people from local universities, from local universities in the East African region. We recently were thinking about them and how, and actually made an application for a proposal to use AI for indigenous knowledge systems for ensuring proper land management and climate mitigation. So there are potential areas there. Thanks.
Thank you very much, Dr. Law. I've seen two more questions. Maybe we can end there. The first one of the questions.
For indigenous language, I think there's more to go, because if you assess the local language landscape, especially in Kenya, we do not have a database or a data set which actually amplify or try to convert this language to knowledge-based. For example, in my own language as Aluya, I don't have a database actually to convert this language to machine learnable or AI. I feel like it's a contrast, because it's a long way unless we have the experts to convert each and individual language, so that we can easily, the language model can draw the language or the inferences from this language to give that knowledge which is required. Actually, now we are so happy that big language models are coming up, but it takes a while. It will take a while. That's obvious, because if you don't have the data sets like analyzing the Lia language, the Kalenjin language, the Oromo, the Somali language, then we don't have this happening soon unless experts try to convert this language to AI. So what we have now is English language, and that's practicable on context time.
Thank you very much, Dr. Luvembe, for that, and also Dr. Two more last questions, maybe for this. How can we use big data and AI in land governance to achieve sustainable climate resilience through policy? The question that was asked, and then the second, we use AI in habitat restoration. Maybe I'll start with Dr. Law, Dr. Rendan. Maybe I finish with Dr. Alex. Then you can close the chapter.
I can give a quick answer on the governance. A big part of governance is just being able to map the land, the actual land. So how big data, especially high resolution remote sensing data, can be used in this particular way is first to map accurately the land that I think that is straightforward. As a straightforward application. One of the examples of data that I talked about as I was speaking was a field, and the fields of provides all data or digitizing for segmenting parcels. A good thing is that of that data in Rwanda, I see that potential fast way using AI by facilitating land
Thank you, Dr. Lo. Maybe Dr. Rendani, how can we use AI in habitat restoration?
Mm-hmm. Yeah. So I think what Dr. Olo said is 100% on point. I think what the main thing where AI comes into play there is with integrated with remote sensing. I mean, land use management is a big area where you detect what shifts. I mean, there's actually very good data sets where you can get a time series of changes in land use. And changes in land use have a lot to do with, I guess, habitat deterioration or perhaps even restoration. I mean, there's now very good work that's being done on detecting, say, for instance, significant events like wildfires out of satellite imagery, where you can actually see the smoke from satellites and so on. So I think that's a big thing. So where you can have automated detection at high levels of skill or accuracy based on satellite using AI, I think that's going to be a big area. And is already showing fruit across Africa. I mean, for example, there's the open buildings. I think it's a data set that has just emerged out of Accra, Ghana, which essentially maps every settlement across the continent and globally, which is very important for checking human migration patterns, which are very significant when formulating future scenarios or social progressive pathways. So therefore, and that affects how we look at climate change, for example. So I think it's, when integrated with remote sensing, you'll get quite a lot of value from AI in this particular area.
Thank you, Dr. Rendani. Maybe Dr. Luvembe, you can just finalize the question and answer session by how can we use AI in trying to address the issue of climate resilient water management and also the issue of genetic erosion in agriculture. Dr. Luvembe, we lost you. Maybe Dr. Olo?
Yes. A classic example is in Nanjing in China and Shanghai, where I'm based now. Like now they're using like satellite images to map land use, mostly for residential and agricultural part. And this mostly is used using the satellites. Like they can actually use the satellites to map the land use, maybe for commercial, residential, and so on. In Shanghai, actually, they can actually use the satellite images, radar data, and Internet of Things, this big data, actually to map potential areas for different activities. One, in the local context, more need to be done because actually we know we don't actually have the data sets to actually assist us to map potential areas. We do not have the satellites. That's the key. And we don't have these heavy machines to do this satellite imaging and classification of potential areas where we can actually have these aspects giving specific spaces for agriculture, residential, and so on, or commercial aspects. Pollution is all over. But if maybe we have these mechanism or models, heavy machines which can harness to actually process different environmental factors for given aspects, then IoT satellite imagery and radar information can actually be used to actually map specific areas which can actually be used to space these specific areas for residential or whatever, or agricultural spaces for sustainable well-being of the society, actually.
Thank you a lot, Dr. Luvembe. I think we have quite a lot of questions, and we shall be able to also take note of the questions. And even as we do the report for this webinar, we shall incorporate that in the report so that at least all the questions are addressed. Back to you, Dr. Taylor.
Thank you, Humphrey, and the presenters for answering the questions. Indeed, there's so much to be looked into and to be discussed, and 2 hours might not just be enough to even answer 1% of the concerns that we have. But 3 things come out of this conversation as I usher in Professor Lago to close for us the webinar. Number 1 is that there's already a lot going on in different parts of the continent with regards to AI, whether research, whether capacity building, whether practical application. But I do think that there is need for better coordination. There's need for better sharing and engagement so that we can see some systematic progress in the AI for climate action field. That's critical. Number 2, the element of capacity building is still very important. Going by some of the questions that are emerging from the discussion, there's quite a lot of excitement among different stakeholders, early career researchers, students, practitioners, policymakers who really want to engage or sort of venture into this field of AI, and they have the passion, they have the interest, and perhaps the background. So the question is, how do we structure a very systematic capacity building that is going to really target the right people, the right skills, and the right kind of topics? So that's very fundamental, that as a people or as a community, as a group, we need to think about in a way that we sort of enable skills transfer, sharing, and we enable a delivery of a capacity building model that is actually impactful and actually is going to enhance the applicability of the AI skills. And finally, on the issue of institutionalization, I think there's a big challenge there. While capacity building is part of institutionalization, because then the people who develop their skills are able to really transport or transfer these skills in their different institutions, whether government or non-government or practitioner institutions. There's still a lot to be done in terms of putting in place the necessary infrastructure that could help to support the application of AI skills. The fundamental point again that has come out in the institutionalization is the issue of social differentiation, gender issues. And finally, a key point that come up again in the institutionalization part is the element of how do we prepare our existing system? Because Africa's systems, whether universities, whether government bodies, they're already systems, data platforms, they're already laboratories that are there. They're already modules that are existing in this particular context. But how do we make them responsive to the demands and expectations of AI? How do we decolonize them so that they are able to be adaptive, they're able to be flexible, they're able to provide room for emerging innovations such as AI? Because again, without that particular institutional home or institutional foundation, then it becomes very difficult to strengthen the application. Those are some of the 3 kind of reflections that come out of this engagement. And I want to say from the Africa Research and Impact Network, we are going to continue working with you to pursue these questions and concerns, and we'll be able to, speak to some of our, partners and funders. How can we support a very functional and cohesive, coordinated community of practice on AI, so that, the different facets of AI progress, activities, impacts, the things that are happening, in different places can actually be made visible and can be well understood by the stakeholders in this particular continent. And I want to say again, from my side, I've been the moderator of this webinar. My name again is Johannes Atela. I'm the director of the Africa Research and Impact Network, and it's been a pleasure, having this conversation. We still have 105 in the conversation. That shows the interest and the passion that you have for this topic, and we don't take it for granted. Thank you so much for all your time and contributions, and thanks to our presenters. You are amazing and wonderful. We are going to keep this going. moving forward. Professor Olago, the Director, Institute for Climate Change and Adaptation, University of Nairobi, is also part of this research project. Welcome to have your concluding remarks webinar. Thank you.
Yes, thank you very much, Dr. Taylor. And this has really been a very opportune and wonderful moment to share and to see how AI really cuts across all dimensions of our lives. And it is the right time now to bring it in to answer the many questions that we have in terms of climate adaptation, mitigation, and building resilience to climate change. We have many partners here, and I hope that this network of community of practice that will bring in the AI applications into all the different dimensions and disciplines that should work together to bring together the goal of actually building sufficient capacity and skills to ensure that we can answer all the problems that are facing us as a society. So I'd like to just move a vote of thanks to ARIN, Dr. Taylor and the team there, to the team in ICCA, to the presenters who have been here, Dr. Lois Ochanda, Dr. Francis Olo, Dr. Munyole, Dr. Ramdani, and all the participants who are here present. Thank you very much for giving us your time and ideas in this discussion that we have had. This is one of many which will come to follow. And so we would also like to thank the IDRC, which has funded this project, making this possible to take us further into the future. So thank you all very much, and God bless. Have a nice weekend too. Back to you, Johannes.
No, thank you. Thank you so much, everyone. Have a lovely weekend.
Thank you.
Thank you. Bye. Bye.
Thank you.
Thank you. Bye.